Thanks, Kim. Well, welcome to Innovation Insights. My name is Jason Gibson, and I'm the CCO at IACMI. Innovation Insights is our premier monthly webinar series designed to spotlight the innovations, the people, and the partnerships transforming composites and advanced manufacturing across the U.S. As part of the Manufacturing USA Institutes, IACMI is at the center of composites innovation, leading national efforts to advance cutting-edge materials, scale sustainable processes, and strengthen U.S. manufacturing competitiveness. We exist to convene, connect, and catalyze. And what I mean by that is we convene members of the composites industry to share insights and opportunities where they can connect with all levels of the industry, from OEMs and small startups to academic institutions and national labs. And finally, to catalyze meaningful progress through collaborative technology development and ultimately to commercialization. Today's Innovation Insights session is part of that mission, an opportunity to highlight new ideas, emerging technologies, and real-world applications. We're glad you're here, and we hope you walk away both inspired and informed. And for those of you who are new to IACMI, our mission is to accelerate the development and adoption of composites and to strengthen U.S. manufacturing and workforce competitiveness. We offer broad value through a unique combination of innovation-focused projects, co-funding opportunities, and access to state-of-the-art facilities. Our strong networking platform connects across the composites market, fostering collaboration and alignment. So if you're listening today and you're not currently an IACMI member, we encourage you to consider the value of joining. When you join, you'll be able to engage directly with peers across industry, academia, and government, collaborate through our working groups, and shape the future of composites innovation. Whether you're a startup, OEM, or supplier, there's a seat at the table for you, and the return on engagement can be significant. We'd love to have you involved, so please visit our website and reach out to us by filling out the online form. So every year we gather all of our members for an in-person meeting where we're able to connect and really engage in getting to know one another. This is always a great opportunity to connect with other members that you haven't been able to in the past. And I highly recommend to everyone listening that if you aren't currently a member, become one, and then do your best to make the time to attend this annual meeting. I'm going to share a short video detailing this year's members meeting in Dayton, Ohio, where we celebrated our 10th anniversary.
Welcome everybody to our members meeting 2025, and we are turning 10 years old. How time flies. It's very appropriate that we are here tonight celebrating our 10th birthday at the birthplace of aviation in Dayton, Ohio.
We couldn't wait to come back here again this year. Anybody in the market will be here. We've had a lot of good discussions back and forth. Both of us are saying, you're exactly what we've been looking for. So we've been looking for people who need what we have. There's a lot of people who are looking for what we have.
Every supplier, every manufacturer in this industry has some secret sauce, some technology expertise, some subject matter expertise that they're very hesitant to share. What I've seen is that IACMI has done a great job of creating an environment where companies can share information, share ideas, and so that kind of collaboration and innovation allows new technologies, materials, processes to be developed that can then go to market and help solve problems.
The exciting thing when you hit a 10-year anniversary is you can kind of step back. Projects then form the basis for other projects standing on their shoulders, if you will. Over the years, the net impact grows and grows and grows. These have turned into new companies or expanded companies, and they're part of the success story. That's the largest impact of the Institute.
So looking back on the last 10 years, I think it's incredible the scope of projects that you guys were able to fund and to drive that innovation to that commercialization stage.
This time I decided to have almost speed dating, business-to-business tables. You know, just brings immediate value to our industry partners that, you know, how often does a small supply chain partner have a chance to meet with Anduril or Lockheed or Northrop Grumman or Boeing or what have you? We had, I think, close to 250, industry partners coming through the Dayton Composite Center for a tour, created great awareness of what we're doing.
To get to meet and network a lot of the people and a lot of the members that are there, it was very beneficial to our company.
The members meeting is impressive. The amount of involvement and engagement from everyone, from industry, from universities, from government agencies. It's really incredible how we bring together that group of people so that we can really convene, connect, and catalyze. All right, so if this is your first time attending Innovation Insights, we encourage you to explore past episodes that are available on our website. Since its launch, we've hosted over 42 episodes and featured more than 118 members and partners, each one sharing real-world applications, technical advancements, and lessons learned. Innovation Insights not only keeps you informed on the latest trends in composites and advanced manufacturing, but also provides a direct connection to thought leaders and innovators in the field. And today is a good example of that. So, let me introduce you to our speakers for today. We have 3 great presentations covering technology, industry needs, and workforce development. We're starting off today with a presentation from Airbus because many of IACMI's members ask for help in understanding the technology roadmaps our larger OEMs are pursuing. So in response, I've asked Tim Gaur of Airbus to share how one of the world's leading aerospace companies is approaching the future of manufacturing and the role of advanced materials. Tim is the Senior Program Manager for Research and Technology at Airbus Americas in Herndon, Virginia, with a focus on advanced manufacturing and material technologies. He's been in the aerospace industry for over 25 years and held numerous engineering and program leadership positions in both the commercial and defense sectors. Prior to Airbus, Tim worked for other major OEMs, including Sikorsky and Lockheed Martin, as well as Eaton Corporation, which supplies major components to the aerospace industry. He has an undergraduate degree in aerospace engineering from the University of Maryland and an MBA from George Mason University. And then next, we'll hear from Nick Evans and Leticia Oliveira with Composites One Aerovac. They'll highlight customer-driven process materials that enable smarter, more efficient composite manufacturing. Leticia is a materials engineer with a focus on polymers and composites, holding a bachelor's degree from the Federal University of ABC and a master's degree in materials engineering with an emphasis on composites from the University of São Paulo. She has over 10 years of experience in the composites industry, having worked in raw material manufacturing, composite part production, and now in distribution, which gives her a broad perspective across the entire value chain. Leticia currently works as a process materials specialist at Composites One and is based in the U.S. Nick is the technical director for Aerovac. He has over 30 years of experience in laboratory, manufacturing, and commercial roles within the composite industry. Nick works closely with manufacturers and customers across all sectors to improve efficiency and innovation in composite production. And then our last presentation will be given by Greg Harrell from IACMI. He'll share how the Metal Workforce Development Program, while focused on metals, integrates composites expertise into hands-on training, online curriculum, and career pathways, helping to close critical workforce gaps and strengthen U.S. manufacturing across multiple advanced technology sectors. While many composite-intensive applications, like wind turbines, aerospace, and defense systems, still require high-performance metal components, strengthening metals and composites together ensures the U.S. can meet demand for both. Greg is the workforce coordinator for ACME's metal program, bringing over 20 years of aerospace and automotive manufacturing experience and 15 years in K-12 education. He specializes in CNC machining, metrology, investment casting, and forging, and is passionate about training and connecting students and communities to high-demand careers in advanced manufacturing. So that's the slate we have for you today. I'd like to turn it over to Tim Gaur to start his presentation on what Airbus is doing. Tim, and let them present on their product. Looks good. We can see it, Nick. Go ahead.
Mick, you're in mute.
Good morning, good afternoon, everybody. Thanks, Jason and the team, for the opportunity to present to you all today. My name's Nick Evans. I'm the Technical Director at Aerovac, and along with my colleague today, Leticia Oliveira, we will be presenting some of the products that we've been working on in collaboration with our customers and some of our customer demands. There we go. So a little bit about Composite One and Aerovac. So Composite One is the largest distributor of composite materials in North America. We have over 600 material suppliers, and we have over 45,000 product lines. So that, along with 50 locations within North America, I'm pretty sure that these guys and Composite One will be able to find something that's going to be able to support you in your composite production. Aerovac is part of the Composite One business. We're one of the largest manufacturer and supplier of process materials, so including bagging films, release films, breathers, peel plies, sealant tapes, and everything else that goes along with composite manufacture, including reusable rubber bags, pressure intensifiers. We have 5 sites within Europe, 2 sites in the UK, 2 sites in the south of France in Toulouse, a site in Italy, and we also have a site in Brazil and a dedicated site in Salt Lake City. So we supply not only roll stock, but we also supply pre-cut products. We also supply slitted products as and when required for the customer. So Aerovac's vision statement is that we'll be valued by our customer as the most dynamic, innovative, dependable supplier of process materials. So with that in mind, we'd like to share with you some of the products that we've been developing with our customers. We'd like to discuss with you further the StretchFab 4000 bagging film, our Combi One multifunctional product, and also our A100 peel ply product. So one of the issues we've been experiencing hearing from our customers is that there's a requirement for a high performance bagging film, especially when we consider the Aerovac supplying materials all around the world. And when we look at those environmental conditions all around the world, so for example, as we've got here in El Paso, Texas, where we've got really high temperatures and really low humidity conditions, this can have a detrimental effect on some nylon bagging films. So the feedback that we were getting from some of our customers is that what we'd really like to see is to see a tougher film that can cope with these sort of temperatures and these sort of humidity levels, and also that we can see a film that had a higher mechanical properties as well, so something with a higher tensile strength and a higher elongation. So these environmental conditions, well, some people have the luxury of having temperature and humidity and a dust controlled clean room. That isn't always the case, and some of these high temperatures and low humidity conditions can really tend to dry out the film and make the film feel like crispy and make it feel brittle. So Aerovac took this on board and responded to our customer's request, and we developed a StretchFab 4000 as a film to address some of these issues. So StretchFab 4000 is a high temperature nylon film that's suitable for the aerospace industry, is suitable for wind energy, automotive and industrial. This is a good high temperature performance. It's a tough film with a really high tensile strength values and really high elongation values that we're seeing well into the 650, 700% elongation. So really good for those really complex shapes that we typically see within the automotive industry or within the aerospace industry. The film is really good for polyester resins, vinyl ester resins, epoxy, and even some of the aggressive resin systems like BMI and phenolics. It's available in the common formats such as lay flat tube, V-sheet, and standard sheet product, and we're also able to weld and heat seam this product to either wider widths or some complex shapes as well. So all this being said, this is now a film that's stable under those tough environmental conditions, and also gives a really kind of good mechanical properties for tensile strength and elongation. So how did Aerovac do that? So we took a look at the polyamide groups, and they tend to have a strong hydrogen bond in the polymer chains. So in those normal humidity conditions, the moisture within the air tends to make the film flexible. It makes it feel soft and easy to work with. But in those dry environment conditions, the hydrogen bonds form really tightly, and you get very movement within the change, and that forms the film to be quite crispy and quite brittle, and can be difficult to work with. And there's always a risk that there's going to be some cracks, or there's always a risk that it's going to be, cause some issues, especially in bridging and so on. So what Aerovac team did is that we looked at developing a specially developed production formulation, where we could then look at modifying the polymers to make the chains more irregular. So what would happen then is that the moisture that's within the chains and within the plasticizer keeps the film more softer and makes it easier to work with. That's also given us higher mechanical properties, as you can see there. We start to look at high tensile strength values at room temperature of nearly 100 MPa, and really high elongation values of nearly 700%. Letitia?
Yeah. So another point that you see a lot in the market is we need to be more efficient in the process. So we also think about smart process materials to make your process more efficient. In composite manufacture, there's many types of process materials, each one with specific function. They're usually applied in the same order during the production. So in complex process such as blade repair, where the guy is doing some repairs in the top of the turbine, or there's other process that is challenged as well, we develop a product that has multiple individual layers together, so you don't need to apply one by one. Your solution is developed in combination materials that integrate multiple functions in a single layer and eliminate need to apply materials separate, make the process faster, simple, and more reliable. Next, Nick. This is the Combi One, so we can use in different markets like wind energy, automotive, marine, industrial. It's a combination of release film, pupil, and mesh. It can go to almost 250 F. We have a standard size, but we can split it in smaller one. So in this product, we have 100 PS pupil that's clear with pink stripes, so it's easy to identify your part. You have normal release film P16, and also you have a knitted mesh VI1 that was really conformable, so you can use in different geometries. Yeah, so here where you can apply it for repair business, repair wind energy business, but for sure you can use for different other market as well. This is an example of hand layup with vacuum process after. So you have the Combi One set up in the correct size of your part. When you're doing the repair, you in that case is hand layup, so you know exactly the size of each layers, and you add the resin system. When you finish to set up the repair, you only warp one layer of the product that helps with three different parts of the hand layup process. You put the vacuum line, and then you seal everything with the bagging film. After heating, you are ready for done. So one product that make function of three different products in one process and help the process in the repair business be much faster and efficient. The other thing that we talk a lot is the future in mind. So we also developed some process materials designed for the future in mind. All the process materials, bagging film, fabrics, whatever, were used only during the manufacturing, and after that we discard after the cure. These process materials are proton-based, and once the thermoset contaminate, it's almost impossible to recycle. So, for example, for 2024, only for the wind energy that we produce around 3,000 blades, and you waste around 300, 400 kilograms of waste for blades, we are talking about throw away 9 to 12,000 of tons of petroleum-based product. So your solution, develop a bio-based product to minimize environment impact and provide more sustainable solution. This is 800 PS Eco. we can use for different applications like aerospace, wind energy, automotive, marine, and industrial as well. Is a porous nylon 5/6 pure ply, maximum temperature 400 F. It also has a standard size, but you can split it. It's easy to see in the process because it's with print stripe. And after we remove for apart, it's good for second operation like painting or bonding. It's recommended for most resin systems except of phenolics. So sometimes the phenolic is good due to do some tests to make sure that it's compatible with. So why 100 PS equals is a bio solution? Because this is the process of production of that. It's come from the corn. So you process the corn, extract the starch. This starch is converted into glucose, that a simple sugar. We use this glucose with microorganisms and produce some kind of acids and amides. In the case of polyamide 5/6, we have a special monomers that we name as PMGA. And this PMGA, when combined with a deep acid, will form a polymer chain. So as the PMDA is renewable origin, so it's part of like plant source, it reduces your carbon footprint. This is the important part for like bio-based. You decrease your carbon footprint. And polyamide 5/6 is a really good mechanical and thermal properties, really similar that you see in the market for polyamide 6 and 6/6, and also have different able to certify and attest the bio-based contact on that. Nick.
With that in mind, Aerobus is going to continue to develop and adapt to the requirements of our customers' needs. So along with the recent introduction of the StretchVac 4000 product, we'll continue to look at multi-layer bagging films. So we're looking at bagging films that have release properties to them, not only for cost efficiencies or economical bagging films, but also high temperature, high performance bagging films with release properties to it. Along with the Combi One that Letitia has presented, we're looking at developing more products that benefit with efficiency. So multifunctional films, so films that are bagging film and release film combined, but during the production process won't necessarily need any breathers in the production process. So there's some efficiencies, and not only that, some cost savings to be had with that application. And these films are also good for autoclave cures as well, up to 7 bar in pressure. And then Aerovac continues to look at the sustainability route and the natural fibers. We were looking at natural fibers for breathers, so we're looking at jute materials and lignin and hemp. And we're also looking at sealant tapes with an 85% less biomass monomers. And we're also encouraging recycle programs, not only with our production facility, but also with suppliers and with customers. So we have a number of projects that are ongoing within all these areas. And that's it for us, Jason.
Thanks, Nick. Thanks, Letitia. A couple questions for you. I find that the bio-based system, Polymid 5/6, I think you said was the chemistry, and you're using it for a peel ply now. Is it applicable to other areas of process consumables like bagging films and release films? Do you see it going into those areas as well in the future?
Yes, we have some. We can try. It's more warm to the warm than films, but yeah, there's another solutions like we are talking about, as Nick mentioned, about like some kind of natural worms for breeders as well. I think you need to find different kind of raw materials, but yes, for sure, there's another alternatives for that as well.
So is it possible in the future that all the process materials could be truly recyclable and net zero?
Yeah, we are trying to find some bio-based raw materials for this market for sure. This is the key.
Great. On the Combi material, very interesting. What I saw with some flat panels, how do you handle that when you have very complex surfaces where you've got to, drape it and get it down into tight radiuses? How can you simply cut it and overlap it and it still works and the flow still works properly for the resins?
Yes, we have some, if you see the image, we have some kind of overlaps to do. But yes, we have some parts that's make for that, and it's easy to conformable because it's really we use like a conformal mesh for that. We also are planning to do for more combination materials with different structure for different markets as well, so we can like develop case by case as well.
That's great. That's great. All right. Well, thank you guys. It's time for us to go ahead and turn it over to Greg, and let's hear what IACMI's doing with the metal program.
Thank you, Jason. Let me see if I can get my screen to share here. Let me know if you can see that or not. See, share.
Yep, looks good. Thank you.
Awesome. Again, thank you, everybody, for being here today. So let's talk about, like I said, I'm Greg Harrell, I'm the workforce coordinator for IACMI Metal Program, and let's talk about metal. So what does metal stand for? It's Metallurgical Engineering Trades Apprenticeships and Learning. IACMI workforce programs. We're talking about composites here today, and I guess it's kind of odd to hear about IACMI talking about workforce programs here. And one thing that IACMI has been successful in is the advancement of composites and through the Department of Energy. So what we decided, we were asked by the Department of Defense to come up with some workforce development programs, and that's just what we have done. Through programs like our metal and ACE and our K through 12 initiatives, we're working to rebuild America's manufacturing workforce. And why is that important? It's because we have to have supply chains and have critical people in those rows to support that. And what's great about these programs are, they're basically free and at no cost to the participants. And the participants that come through these programs, what they're doing, they are reindustrializing America. They're bringing back critical trades and are upskilling our workforce, which is everything what we've talked about here. We've listened to Tim and Nick and Letitia and talk about the criticalness of their products that they have, and those rolls right into that. So the missions here at IACMI is always to produce better processes, better products, and better skilled people, and that's exactly what we're trying to do. So from composites to metal, metal drives our supply chain resilience. And what metal is doing here is we're actually ensuring that we have a robust domestic supply of skilled workers. And why is that so important? I mean, just like we talked about here with our other presentations, is support composite-based technologies. And of course, we have to have, with those new materials we have out there as far as composites, we got to have, requires higher performance metal components. We've got machinery, tooling, modes, dies, and things like that. And we have to have skilled people to be able to create those for our high need areas such as that. So of course, we also know that 90% of our all durable manufacturing goods is created either from a casting or forging. So that's why it's so critical. The launch of the metal program. So there again, like I said, we talked about the Department of Defense and came through we came through the metal program for casting and forging program collaboration with the Department of Defense. And why is that? Is to close the skilled labor gap. And we know that there's an aging workforce out there. We've got the baby boomers and they are retiring. And a lot of these, they're taking those skills with them as they retire. And so we're trying to build that pipeline and ecosystem to ensure that we have the top training out there and personnel to make those components and fill that need. So we also want to strengthen our supply chain resilience and ensure national security. So if we don't have those folks in place with the skills that need to create the parts, then we're going to have a supply issue. And overall, what we've done here is we've took our ACE program, which is America's Cutting Edge, and our lessons learned there and turned it into our middle program to ensure that we have a good, robust program with that. So as you look here for the slide that says changing numbers of establishments from 2004 to 2023, we have plate rolling, forging, and foundries. So you can see we've actually had an increase in plate rolling over the years here, but we've also had a decrease in forging and foundries. And also you can see our average age of the workforce down there in your right bottom as well. Metal program vision, we have our 4 E's. We're looking at engage, experience, educate, and employ, which this is the heartbeat of our operation here. So how are we engaging? We're engaging those K through 12 students through metal workshops. And what does that entail? It's a lot of hands-on activities where they're making molds, pouring metal, usually about 3 hours in duration. So we're during that time, we're hoping to just spark that interest in material science and metallurgical type processes. We also have our metal online curriculum that we use. We also reach out to large STEM events, to large audiences, so we can actually reach out to them as well. Experience, we have our in-person level 1 boot camps that we do, which we go through the casting process where they learn lost foam, sand, just basic modeling. They create molds, and then they'll create those molds. They'll pour metal into those molds. They'll process those parts that they create. And then we'll do some lab work. We'll do tensile strength and things like that and learn about it and just learn metallurgical basics. And like I said, there again, you're learning those hands-on activities you got there. And through these boot camps, we get a lot of students that come through there, especially engineering students that's never got that hands-on experience of using hand tools, drills, and things like that. So it's great for them to get their hands dirty per se. So also we have our educate pathways here. We're looking at education. We have our level 2 and 3 boot camps that's coming on. They're actually in development, and we'll talk more about that here in just a few minutes. Then ultimately want to employ, just like you said there, we want to make sure we have a robust employees that come in that's marketable and come into our industry where they're ready and skilled and have the training that they need to go right to work. So we want to make sure they're employable. Where are we at? So right now we have 7 metal training sites across 6 states. We're at Michigan Tech, Penn State, Ohio State, Cal Poly, the University of Tennessee, Tennessee Tech, and the University of Alabama, Birmingham. And to date, right now, we have a total of 4,922 outreach events. Direct engagement, we also have 883 total online registrants. We have 562 total in-person workshops and participants, 229 total in-person bootcamp participants, 37 total interns placed, 33 total registered apprentices placed, and 22 total pre-apprenticeships placed. Our metal online or metal learning pathway, we have our metal level 1 online modules, which is typically about 8.5 hours in duration. That is self-paced. You can do them on your own time, start and stop as you like. We have our metal level 1 in-person boot camps is usually 4 to 5 days, where they come in, do all the hands-on activities. We have our 3-hour workshops where we target 6th through 12th grades. We have those are also in schools and also at our hubs and spokes, our universities and colleges, which entail sand casting, investment casting, and forging. For K through 5, we have a chocolate castings that we create for those. Very popular with those kids. Who doesn't like chocolate, right? So engineering and practical engineering units for apprenticeship programs. We've acquired 22 units from Goodwin Steel. We have some we're getting ready to release here, which is welding, liquid metal casting, CAD engineering, and mechanical measurements, which will be delivered nationwide through our campus there. And again, that's going to be for our apprenticeship programs. We also have a VR tour of a forging facility, McInnes Road Rings. So you can't get to the facility, we can at least bring it to you through VR, which is great for anybody wanting to see exactly what it entails in a forging facility. We also have our metal advisory network, which we call the MAN. We have a very diversified group. We have a lot of industrial representatives from small, medium, and large companies. We have our associations, which is listed there, have a great representation and diversity in our group. We also have our metal partner sites, which are hubs and spokes, which I spoke to earlier, of 7 sites. And the purpose of our MANs is actually to meet quarterly. We share our best practice and we provide that feedback to our metal steering committee. And the most important thing out of that is it's industry driven. We will make sure that we're meeting the demand out there that's needed. And just some success stories. This is Walt and Janelle Jager, founders of Jager Technology Group, and they attended a boot camp at the University of Tennessee. And what they were doing there, they were there to just explore the boundaries outside of the polymer 3D printing business they were in. And what they learned there, they went out and they talked to some other businesses. Within a few weeks, they were able to secure about $20,000 in new business. And the great part was there's a lot of parts they found that was actually offshore. They was able to reshore in their business, which was a win-win for everyone there. And then we also have a retired NFL linebacker, Tim Johnson. He joined a metal boot camp at the Ohio State. He explored how metal castings could strengthen his brain crown helmet, which he's very passionate about, wanting designed to protect athletes, service members, and first responders from traumatic brain injuries. And got a little story about him, a little video on him here, a little more in just a couple of minutes. So just some more success stories here. You have Hannah Desai, who is an FEF intern, and she did some foundry work there, where she did an internship there, and she just talked about how pivotal that experience was to her career. Also here with Will Gaur, he was a UTK boot camp participant. Same thing, he actually came through our ACE and Metal program, and after he came through this, I think this program that he came through was in May. He actually had an interview. He's a mechanical engineer. He actually had an interview at a local aerospace company, and he says that it was critical with the experience he got from the ACE program in Metal. It definitely helped him stand out from the other 50 applicants for that job. And also last year we have Bentley Lewis, an 8th grader, talking about his first casting experience at a metal workshop in his middle school. Kind of funny here, he created a mold. He poured the metal in there, just couldn't believe it filled up so fast. Didn't think it was going to work, and it came out having the best chess piece ever. So some great stories here, testimonials shared, and that's what we're out to do. Like I said, all this stuff is that we do is hands-on, giving that experience and learning, and sparking that interest in the metallurgical type processes. Just a couple of videos here. The first one is Tim.
I'm Tim Johnson. I'm from Fairfield, Alabama. Played for the Baltimore Ravens, the Chicago Bears, and the Oakland Raiders. I went to Youngstown State University. I went back and completed my degree in 2014. I'm the founder and CEO of Head Impact Prevention, medical doctor, HIP MD. Saw a metallurgy class here at the Ohio State University. I was excited about it. I wanted to learn more about metal, more about the CAD and 3D printing of it. This boot camp has been amazing. The last 4 days, each day was packed with knowledge and information that we can apply in the real world. Maybe a job or something opens up in the future that I'll have the information and knowledge that I need to be successful in that.
One more video.
Do it, especially if you plan on doing anything in the industry. So many things in industry are made of castings. Just having a little bit of knowledge about how they're made and what goes into it will help you no matter what side of it you're on.
And all that footage there is actually from our actual boot camp. So you can see how it's all very hands-on, pouring metal, making molds, and creating parts, everything that you want to make an experience in. So where is metal going? Right now we're looking at our metal program expansion strategy. We've taken the data, taken the strategy from that. We're accelerating our metal expansion nationwide. You can see the map up there on the right top. You can see where we're actually using that data to make sure we're getting in the right places where the industry is. We're also deploying mobile foundries to bring training to outreach to rural areas and communities, which is very important. We're also embedding metal workshops into middle schools and high schools. We're wanting to spark that interest in those students to go into types of material science and metallurgical programs where they may not have that. But we're also advancing our metal curriculum, our metal level 2 or metal industrial specializations like metal alloys, compounds, sand science, foundry pattern making. And that's actually going to our metal and also our metal level 3, or advanced manufacturing technologies, which proposed curriculum is robotics, automation, AI, AR, VR, and Industry 5.0. And we're actually going to pilot these new, our level 2 and level 3 in October, sorry. We also have our metallurgical engineering certificate programs we're looking at. Also our VR tour of a casting facility, and also online Train the Trainer, which includes videos of each of our activities that we're doing, the workshops and boot camps. And that's all I've got.
Thank you, Greg. That's really helpful. I just want to add, first off, we're running close to the end of our time. So if you do have interest in either the METL or the ACE or even the Integrate type programs that we do for workforce development, if you see a need in your company to help get new applicants into your job roles, reach out to Kim Hooden. She can connect you to Greg or anyone at our workforce development group and help you connect to the programs we have out there. So thank you, Greg.
Welcome.
Let me share my screen again. So I want to say thank you, everybody, for your time. Before we go, I want to note that our next Innovation Insights webinar is on Monday, September 22nd. And then we'll have one in October and one in November. The slots are filling up. We do have a couple left in those. So if you have something innovative you'd like to present, reach out to us. We'll take a look at it. And if we have a slot open, we'll be happy to put you in there. Also, I want to note that we'll be at CAMX, so feel free to reach out to us when we're there at our booth. We'd love to see you there and love to connect with you there. So with that, I want to just say thank you for the privilege of everyone's time, and we look forward to seeing you out there in the industry. Thank you.
Thank you.
Thank you.
See you guys.
Bye.